All right, so here we are in problem set 62. We're looking at square roots, higher order roots, and evaluating using plus or minus, which is related to roots as well. So right off the bat here, I have two situations. I have the square root of 4, and then I have negative square root of 4. Now, square root of 4, if we were going to evaluate that, hopefully people can do that, and they recognize that 2 times itself gets you to 4. Now, what you have to be tricky about here is that you're going to make, because the negative's outside, then whatever the square root of 4 is, you'd make negative, making the square root of 4, which is 2, and negative is negative 2. So that's just kind of the basics of square roots, and I'm really hoping that everybody knows how to do that. Here's another example where we can evaluate a root. So this is a square root of 18, and this might be a bit tricky because yeah, 18 isn't a perfect square, meaning there's no integer times itself that gets you to 18. But one of the things that you can do to kind of get an idea of where it is you can think of the perfect squares that are above and below 18. So I know that 16 is below 18, and that's the closest perfect square below 18, and then above it is the square root of 25. So I can, which is 5. So I can make an estimate for the square root of 18 that it's somewhere between 4 and 5. And when I type that into my calculator, I can confirm that estimate because what I end up getting is 4.24264, right? And that just keeps going. But just kind of an idea to get you thinking about what the values of these numbers are. It might be almost impossible to figure this out without a calculator, but I can get a pretty good estimate or an idea of the value of this number by thinking about the perfect squares that are above and below 18. So that's what we're going to practice next. So here we go. If we're going to try to figure out without a calculator between which two consecutive integers the square root of 10 lies, yeah, the square root of 10 is not going to be a nice integer. It's not going to be fun, but I know that the square root of 9 is 3, and I know that the next highest value would be 16, so I know that the square root of 10 is going to be somewhere between 3 and 4, right? All right, so with other root systems, like here's a cube root and here's a fourth root, another cube root as well, it's a similar type of thing. And I know that I've talked to a few of you in class about this, but a cube root is saying, well, this is something times itself 3 times, right? So in the case of 8, the cube root of 8 is 2 because 2 times 2 is 4, times 2 again gets me to 8. All right, fourth root of 81. I got to think of the thing that multiplied by itself 4 times to get me to 81. Well, that thing would be 3, because 3 times 3 gets me to 9, times 3 gets me to 27, times 3 again gets me to 81. What's cool about odd roots, rather, like the cube root, that I'm about to look at in a second, is that you can actually take cube roots of negative values because you can multiply negative values times themselves 3 times and get negative values. So that's a little bit of a difference between odd roots and even roots. So in this case, we're looking for something times itself 3 times to get to negative 27. And that thing is negative 3. Negative 3 times negative 3 gets me positive 9, times negative 3 again gets me negative 27. And one other thing to note about roots is that if you're solving equations, you have to be really careful, because down here, when I look at the plus or minus thing, I've got x squared equals 4. Now, hopefully we know from previous classes that the way that you would deal with this from an equation solving perspective is that you would square root each side. Because square rooting undoes squaring. So what would be left on the left side is the x, and what's on the right side is the square root of 4. Now, what's really important to note here is that there are actually two values that the square root of 4 could be. And those two values are +2 or -2, which is why when we solve equations that involve square rooting, we need to take into account that it could be +2 or -2. All right, finally, we're going to end here on just some quick evaluation of an expression here that involves some squaring. So let's take a look at this. So this is really important, and it comes down to an order of operations thing. There is a difference between -2 to the second power and the quantity -3 to the second power. And this is how it works. With -2 to the second power down here, we're going to take the opposite of whatever 2 to the second power is. So 2 to the second power is 4, and the opposite of that is -4. So when I evaluate that with the exponents, I get -4. Now as I go to figure out what the quantity -3 to the second power is, well, that's -3 times -3, which actually gets me a +9. And I'm just going to write the plus or minus square root of 4 here. I'm going to do my square rooting, so that falls actually into the exponent category of PEMDAS. And this is where I'm at so far. Now I'm going to do addition and subtraction from left to right. -4 plus 9 is 5. And at this point, I've got 5 plus or minus 1. So what that means is that we're dealing with, well, 5 plus 2 is 7, and plus 5 minus 2, whoa, I've got to change that to 2. 5 plus 2 is 7, 5 minus 2 is 3. So this is going to be our final answer for evaluation.